we are going to add and subtract rational expressions with unlike denominators. Now remember, just like when you were in 5th grade, if you were adding and subtracting fractions, you could only add them if they had the same denominator. In this problem, x over 7 minus 4 over 5, they don't have the same denominator. Well, we have to get the least common denominator. So I need a common denominator for 7 and 5. Now, many times when you need a common denominator, you can take the easy way out. 7 and 5, well, 7 times 5 is 35. Yes, that's my least common denominator. I will put both of these over 35. But remember, let's just take a little break here. If I had a problem, let's say the denominator is 4, and I'm adding it to a fraction that had a denominator of 12. Would I go 4 times 12 and pick 48 for the denominator? Okay, that is a common denominator. Remember, we really want the least common denominator. So when I look at 12, 4 will go into 12. My least common denominator is actually 12. So let's get back to our work. But this one was pretty easy. I did just say 7 times 5 is 35. 35 is the least common denominator. Now, I can't just change x over 7 to over 35. It's not my birthday. I have to keep these fractions equivalent. What did you do to 7 to get to 35? Hopefully you're saying that you multiplied it times 5. Well, that is just fine and dandy as long as you do the same thing to the numerator. So I'm going to multiply the numerator times 5. So 5x over 35. Remember, 5 divided by 5, anything over itself, it's really just like you're multiplying it times 1. And we know if you multiply something times 1, you're not changing the problem. Once again, I can't change 5 to 35 just because it's my birthday. I must have multiplied this denominator by 7. That's cool as long as you multiply the numerator by 7. Because we all know 7 over 7 is just 1. So in the numerator, 7 times 4 is 28. I have a like denominator now. That is great. My answer will be over 35, and that will be 5x minus 28. Can I factor the numerator in order to reduce? No. Could I reduce this 5 and 35? No. This is 5x minus 28. That is not just 5x. We have x plus 5 over x plus 2 plus 6. 6 is just over 1. What is my least common denominator? Your least common denominator is x plus 2 times 1, which is just x plus 2. So I want to write both of these fractions over x plus 2. In the first fraction, did I do anything to that denominator? I had x plus 2. I still have x plus 2. In the denominator, I had 1. And now I have x plus 2. We can't do that. I must have multiplied the denominator by x plus 2. That's fine and dandy as long as you multiply the numerator by x plus 2. Remember, x plus 2 over x plus 2 is just 1. So in the numerator, I will have to also multiply the 6 times the x plus 2. Okay, let me warn you about something. Many students skip here and they have a brain freeze and they think, oh, I should cancel these x plus 2's. Well, hello. Why did we make it x plus 2 in the first place? We made it bigger on purpose so we would have like denominators. So don't go backwards now and cancel them out and you're just right back to where you started. I have a like denominator. I know my answer will be over x plus 2. And this is a place where another careless error could occur. So it may be best to keep this second numerator in a parentheses. I will go ahead and use the distributive property, so that will be 6x plus 12. It wasn't a big deal this time to keep it in the parentheses because I just had a positive in front. But sometimes it's better to go ahead, distribute the 6, keep that numerator in parentheses, and if this was a negative, I would clearly see, don't forget to distribute the negative. Let's carry on. In the numerator, I have some like terms. That will be 7x plus 17. All of that will be over x plus 2. Nothing will factor. I cannot cancel these x's. This is not x. This is 7x plus 17. In the denominator, this is not x. This is not 2. This is x plus 2. It is a binomial. We now have the problem x plus 2 over x minus 1 plus 6 over 7 times x minus 1. So what is my least common denominator? I need an x minus 1. In this denominator, I need a 7 and a 7 times x minus 1. Well, I've already said x minus 1. I'm not going to say it again. Remember, you don't want your denominator to get too big. You want the least common denominator. So, my least common denominator is 7 times x minus 1. That is what I will put both of my fractions over. In the first fraction, did I have to change it? Yes, I did. I multiplied it times 7. I had x minus 1. I now have 7 times x minus 1. Is that cool? No, it's not cool. I know you're saying it. You're saying, it's not your birthday. I can only multiply that if I want to keep that fraction equivalent. 7 over 7 is just 1. And 1 times anything is just that thing. 1 times love algebra is just love algebra. I'm going to multiply them both by 7, the numerator and the denominator. Be careful. I'm going to leave this in parentheses for now. I will distribute that in a moment. In the second fraction, it is the same. I didn't change it. So I will not change the numerator either. I have a common denominator, and it is 7 times x minus 1. In my first fraction, I will go ahead and use the distributive property. That will be 7x plus 14. I have a plus, so I don't have to beware. If it was a negative, I'd have to make sure I'm careful. And I don't have a binomial here either. It's just 6, so it's just plus 6. You have some like terms. That will be 7x plus 20 over 7 times x minus 1. Can I factor the numerator? No. So nothing will cancel. Would these 7s cancel? No, that's not just 7. That is 7x plus 20. Some teachers may prefer for you to multiply this back out to 7x minus 7. Be sure to ask them, because they are the ones grading your paper. We have 3x plus 2 over 4x plus 1 plus 7 over x. Yes, I'm adding and subtracting, so I need a like denominator. What will my least common denominator be? I need 4x plus 1. That's one of my factors. I also need an x. Remember, this first x does not take care of this x. This is a binomial, 4x plus 1. This is x. So, my least common denominator needs both of them. That will be x times 4x plus 1. Let's carry on. What did I do to the denominator in this first fraction? I multiplied it times x. So, of course, we are going to multiply it just by 1, so we won't do anything illegal. And we know x over x is 1. So, my new numerator will be x times 3x plus 2. I will do distributive property on that in just a bit. In my second fraction, I had x. I now have x times 4x plus 1. So I will multiply the numerator and the denominator by 4x plus 1. So my numerator now is 7 times 4x plus 1. Whew, okay. It looks like distributive property here. This is a plus, so I don't have to panic too much. My denominator will be x times 4x plus 1. I will do distributive property with this first fraction. That will be 3x squared plus 2x. This is 28x plus 7. Now, I didn't necessarily have to put this second numerator in parentheses, but if this had been a minus, it would help me avoid careless errors. Since it's a plus, will any of these signs change? No. But if it was a minus, I would need to distribute that negative. I will have 3x squared plus 30x plus 7. All of that is divided by x times 4x plus 1. Once again, if your teacher wants you to multiply the denominator out into 4x squared plus x, make sure you know what she prefers so you will ace that next quiz. One more problem. 2 over x plus 3 minus 1 over x squared plus 7x plus 12. I am adding and subtracting. I do need a common denominator, and I do know I have a factor in this first fraction, x plus 3. What are the factors of my second fraction? I don't know. I have to factor it. That factoring does not go away. I have 2 over x plus 3 minus, I do need to factor this second fraction. That would be x plus 4 times x plus 3. Now, what is my least common denominator? I need an x plus 3. I need an x plus 4. Do I need to say x plus 3 again? No, you're going to get your denominator too big. I've already said x plus 3. It's accounted for. So, my least common denominator is x plus 4, x plus 3, either order. In the first fraction, I had x plus 3. I now have x plus 3 times x plus 4. So I will do the same in the numerator. I will multiply it times x plus 4. Remember, I am getting this fraction bigger. It's like when you're cleaning out a closet. It gets messier before it actually gets cleaner. When I'm cleaning up this fraction, it looks bigger before I actually get to reduce it. The second fraction, I have everything I need. Once again, I do know that my denominator is x plus 3 times x plus 4. In the numerator, I will go ahead and do distributive property here. That will be 2x plus 8. Don't forget this minus. And this is not a binomial, so I don't have to distribute that negative. It will just be a minus 1. Almost done. In the numerator, I will have 2x plus 7. In the denominator, x plus 3 times x plus 4.